Okay, so what we're going to look at today is polynomial division. And polynomial division exists within the framework that if we have a polynomial to the nth degree with their coefficients, and for this we're going to keep our coefficients to be real numbers, and we'll see why that's important as we progress. And we write all of our powers of x in descending order. We have a polynomial that's expressed this way. This can equivalently be written as the leading coefficient times some factors. All the way up to n factors. Now this includes repetition of roots, multiplicity. And so our big tool for transforming this between these equivalent forms is going to be dividing. We want to be able to divide out our polynomial into factors. And so division with polynomials gets its start, or the best place to look at, from monomials and monomial division, because this tool will be the basis of long division in polynomials, and it'll be a tool that we use repetitively. So let's look at a few monomial divisions. So if I have x squared minus 5x, and I'm dividing it by 5x. Okay, so this will be example 1. Instead of viewing this as one fraction, we can reverse the process that gathered the common denominator in the fraction and link the top. Any mathematical rule we have is reversible. And I'm able to say this. If I am over here, this is equivalent to this. Well, let's look at the right-hand side. I have the same denominator, so I can combine the numerator over the same denominator. Combine the numerator over the same denominator. And so this reversible process breaks this polynomial into two terms where the denominator comes across. And so x goes into x squared, like such. And we get that as the division of this monomial across our terms. All right, let's look at another monomial division. So we'll do example 2. And let's complicate our monomial a little bit. So we'll have 2x to the 4th minus 3x squared plus 4x minus 7 all over negative 4x. Well, we're going to use the same concept. I'm going to take the 2x to the 4th over the negative 4x, but I'm going to pull the negative out front. I'm going to take 3x squared over negative 4x. I'm also going to pull the negative out to the front, so that's a negative over a negative will be positive, right? I'll do some simplification as I move across. Negative 4x over 4x, and positive 7 over 4x, right? A negative over a negative is positive. Negative over a positive is negative. A negative over a negative is positive. And we've deconstructed this into these terms. All right. Well, x goes in x to the 4th. This is negative 1/2 x cubed plus 3/4 x minus 1 plus 7 4x, as this cannot be simplified any further. And we have a format that shows our division of monomial. Notice instead of putting the x cubes up top, I'm pulling everything out front so that we have coefficients. And I'm building a new polynomial out of this. And we could look at this as dividing this polynomial by negative 4x. And we get another polynomial form here with a remainder. And it's equivalent to what we did with divisions with numbers. And so this is dividing by a monomial, a polynomial by a monomial, and how it can help us.